Go Language Programming, Chapter 5, Unit 1. In this unit, we will cover interfaces in Go language, declaring and implementing an interface. So, in many programming languages, many programming languages define interfaces, but Go has a unique way to define interface. In Go language, interface is a collection of methods, and it is also a type which describes the exact methods that some other type must have. So basically, interface in Go language is another kind of a data type. Okay, and it's also has a unique quality that it will tell us about the other data types. So therefore, interface is a set of methods that we use to define actions on the given some other type, such as struct or non-struct. So um, an interface basically um, uh, provide us a way to achieve polymorphism in Go language. Okay, so that's how we can do the polymorphism. Now, the meaning of polymorphism is that multiple implementation, single interface. So that basically means that you have a one single method name, but the same name will have multiple bodies of the methods. So that's what the polymorphism basically means. Poly means many, and morphism means change. So, having um, uh, many more implementation for the same name, you can basically describe the behavior of other types. So that's what we will see in the examples. The general definition of an interface in object-oriented world is interface defines the behavior of an object. Okay, so in object-oriented world like C++ and Java, basically you have in C++ you have a you create the interfaces by using um, a concept of virtual functions, and at runtime you basically the object will be used to uh, change the behavior of itself for different types. Behavior only specifies what the object is supposed to do. Okay? So that's what the behavior in basically even in language like C++ is called the member functions. In here in Go language, the behaviors would be methods that are attached to the different types, like structs or non-struct types. So those methods are considered as behaviors. In Go language, interface is a collection of method signatures that an object can implement. So basically, when you do that, you first of all you're creating an interface type. That type will have more than one or more methods that will um, that will have object that will basically describe the behavior of an object, just like any other object oriented programming. Therefore, interface defines the behavior of an object. So basically, because the methods are attached to a particular type, that those methods will define the when we have a when we have a instance of a type created, that the behavior will define the instance of a type, so which is an object. In object oriented languages they call it object. In here, since Go language is not an object, it's not considered as an object oriented language, but it has some similarities. And basically, that's why you could say instance of some type is also an object, as long as the methods are attached to that particular type. So a variable of interface type can hold any value that uh, implements these methods. So any value meaning any instance of a particular type. Okay. So the whole idea is that I already said that interface in Go language is considered one of the data types. Okay, so when you create a variable of type interface, that variable will hold some value for that particular type. So when a type provides a definition for all the methods in the interface. So how does the type provides the definition for all the methods? Because methods are the one which are attached to the particular type. Okay, and then that's how interface will know those particular methods belongs to some type. So it is set to implement the interface. So basically, once the methods are attached to some type, then we can create an interface for that particular type. So interface specifies what method a type should have, and the type decides how to implement these methods. So when we are talking about this type right here, that means we are talking about struct or non-struct type, which decides how to implement these methods once they are attached to this particular type. So interface specifies what methods type, because you will um, provide all those methods within the body of the interface when you are creating an interface. That's how the interface basically will know about these methods and how they will be used with the particular type. So let's see this example right here. In this example, we have this interface. Um, and in this interface name is shopping. Okay, so this is how you create an interface in Go language. You have a type, a keyword, and then right after the type, you use the name for the interface, and then you use another keyword called interface. And then within the body, so it has a curly braces, left curly braces and right curly braces. And within the body, you are basically creating the relationship between a type that this interface will be used with. So the way that it can happen is if you already have attached these um, uh, methods to the particular type. Now, in chapter 4, we went over how to attach methods. In unit 1, we went over how to attach um, the methods in with a particular type. So basically, once that is done, then you can use those methods name within the body of the interface. So in this case, any type which provides a definition for this a method called buy groceries and buy clothes is set to implement a shopping interface. So basically, any type, meaning a struck or even a non-struck. Okay? In this example, I'm just giving the example for the type groceries of a struck type, and within this struck, I have these fields. Okay, all three fields in within this struct are type string, and basically I have another um, uh, type which is called clothes, and then is also a struct type, and it has two fields in there, winter clothes and summer clothes. So basically, then what we are talking about is attaching the methods to this particular type. And this is what we went over how to attach these methods in chapter 4. So now, basically, we by having to implement this interface, we can say that shopping is an interface to these two types. So shopping is an interface to these two types, the groceries and clothes. Okay, so these are the two types, and shopping is a basically provide us a way to use these fields within these methods, within the body of these buy groceries and buy clothes. Within the bodies of these methods, we can use the fields from these types. So that's how you can tell that basically um, uh, how to declare an interface. So let's look at the other example. In this example, we will go over declaring and implementing an interface. Okay, so this is basically example number 5-1, and like it says, before declaring an interface, first you need to create methods that uh, is attached to the struct type or a non-struct type. Okay, so that's the very first requirement before you can create an interface for that particular type. You first have to have a the methods that are attached to those types. So you can see the in chapter number 4, unit 2, to review how to attach the methods to either to a struct type or non-struct type. So in this example, what we have is um, interface. First we start at line 1, we of course have a package main, so we can compile this code and create an executable, and then we have this um, two packages, and we have been using this package, fmt package, for so we can utilize the print function from this package. Now here we are also importing a math package. So math package is used in this example is because of the pi. That the constant, the pi, that is assigned to the value, to get the pi value, okay, from this package math. So at line number 7, what we are doing, so this example basically is modified by using the chapter 4 example, unit 2. There is example which is example number 4-9, I believe. That is the same example, and all I have done is to add interface which is called shape. Okay, so this is the new code for that example. And then the rest of the code is really the old code. So in this case, what we have for this interface, what we have is a method called area, which is in the body of this interface. And now we have to make sure that we have attached the area method to the two structs that we have, the struct rectangle and then the struct circle. So the rectangle has two fields in their length and width, and the circle has only one field. So basically, what by attaching it, we are what we are doing is to be able to create an interface to access the fields of these two structs, the fields of these two structs within the function body, or the method body, okay, right here. So we are accessing the fields of the struct. So for this one, we are accessing the length and width from a rectangle struct, and for the circle, we are accessing um, within the area method, we are accessing the radius field. Okay, so that is the reason that we created this interface called shape, and it allows us to well, actually, once you do the attachment of the methods to the type, you will be able to do this. So that would be just like the example which is provided in chapter 4. So let's look at the next in the main function, what we are doing, or the entry point function, what we are doing is, so we are creating an instance R for rectangle. And when we are creating the rectangle, at the same time, we are initializing the fields with this data. Length and width is initialized with the data 10 and 5. Okay. So the our instance is created. So that means the memory is allocated at this point. So remember, we are using a short um, declaration, colon equals to, that we have talked quite a bit in the previous chapters. So basically, it is going to allocate the memory for R. Now, where is this memory going to allocate? So this is the memory for R. It is allocated at some address, and in this memory you will have these two piece of data in here. Okay. And basically, this memory, as I mentioned in the previous lectures, that Go compiler decides it can allocate the memory for this instance R in the heap or in the stack. Okay, so it is up to the Go compiler to decide where to allocate the memory, because it will be Go compiler's responsibility to release this memory as well once it is done, by calling the garbage collector that the compiler provides. Okay, so garbage collector will be called, and once this goes out of the scope, this instance will be released. Similarly, we also have the this we create another instance C for circle, and we are basically um, uh, um, initializing the field within the within this uh, uh, um, for this, not within, for this instance. So we are initializing the fields for the circle struct. Okay. Once, so this will be also created in some place in the memory, and it will have 12 in here, and then now in the old code, which is in the chapter 4, we were using the instances to make a call to the area method. Okay, just like this, r dot area and c dot area. Okay, once you have the instances for each struct type, um, you can just make a call like that. Okay, now, but in this example, since we are using the interface, so we used actually a interface to make a call. So this is the shape, is the name of an interface. So we are passing the instances of rectangle and instance of circle to the method, area method. Okay, and now we have created the basically interface between the uh, uh, the types, between two types. Remember, that interface itself is considered a type. So we basically created a relationship between interface type and the specific types. In our case, it's a rectangle type and a circle type. Okay. Okay. So that basically brings us to the uh, next example, And in this example, what we will be doing, going over, is to attach methods to the um, um, attach the method to the non-struct type. Okay, so that's let's go over how to do that. Okay. Uh, okay. So in this example number 5-2, we of course start with the package main, so we can compile this code and execute, and then import these two packages. FMT package we've been importing for IO purpose, and now we are also importing the Unicode. Okay, so Unicode is a universal character encoding standard. So that will provide us characters which basically are for the different languages, like Chinese characters, Japanese characters, Arabic characters. So that's what the Unicode does. And the size of the Unicode is 4 bytes, okay, for each character. So that's the difference. So for ASCII characters, the size is only 1 byte. For Uni characters, the size is 4 bytes. So so it can accommodate basically different languages characters. Okay, that's why Unicode was developed. So um, now in this example, we want to basically go over to find um, vowels within a string. Okay, so to do that, we first create an interface, um, and within, so we have a interface type called vowels finder. Okay, so that is the name of the interface. Now within the interface we have the methods that will basically create a relationship between actual type and this interface. So find vowels is a method, okay, that will be attached to a particular type. So in this case, what we are going over is are using a non-struct type. Okay, so this is a non-struct type string, and so we are basically aliasing this string to this different name, my string. And the reason that we are doing that is because this we cannot use the string by itself in our this code, and we have to do the aliasing because the string is not available within this package. String is in a different package. Okay, so any built-in type basically that are provided by the Go compiler are in their own packages. So that's why it would not be able to see. So that is the reason we have to do the aliasing. And now when we do the aliasing, that means this name right here, my string, can be used to attach a method. Okay, so that is the reason that we are doing the aliasing, because the string itself is not in the same package that that we are writing the code in. Okay, so this is how at line number 12, that's how you do the aliasing. Now what we are doing is, so we are adding at line number 15, we are creating the body for the find vowels method. Okay, and this method is going to be returning the slice of uh, runny. So that's how I pronounce it, runny. So basically, it will be returning the slice of runny. So it can be used um, in a when this method is called, it can be used um, uh, you know uh, to see what characters are there. So that's what this slice is going to be. So the whole slice will be returned. Okay, so the body of this method is basically it's saying that it is to implement the interface vowels finder. So that's what it is creating the interface. Okay, now at line number 8 or 18, we are creating a empty slice. Okay, this is the empty slice. Vowels is an empty slice. Um, or the nil slice. Not, I shouldn't say empty slice. It's a nil slice. Okay, and at line number 19, what we are doing is that we are using a range with the for loop. So basically, in this case, as you can see, that this method will um, uh, uh, be passed a string. So some string will be passed to this method, and that string will be in ms. So basically, as you can see, ms is of type my string. Okay, because my string is an alias of a string type. So now we are using this ms. So we're going to go once the string is passed, we're going to go over character by character in the string. That's why this range is used. Okay, and it will be saved into this name, runny name. So actually, it's kind of confusing. I should have just changed the name right here. This is just like a variable name used. Okay, so this is basically uh, we are using a short notation right here, colon um, um, equals to. Now at line number 20, we are using a switch statement. Okay, so in this switch statement, notice that I'm actually using a package, or I'm actually using a to lower function from the package Unicode. Okay, so Unicode package we already have imported it. So within that package there is a function called to lower. So what we are doing is, whenever we read any character from the string, we are first basically making it a lowercase. Okay, that's why this character is passed to this lower. So once that is done, then what the switch will occur is based on doesn't matter what the character is, it will try to match. If it is a, e, I, o, u, any of these vowels, then it is going to go and append to this slice. You see the slice that we created, runny slice. So then it will append to that slice, and um, basically, so notice also that this is a variable. Okay, and this is basically so this rune is in the scope of this for loop. Okay, this slice is in the scope of the body of this method. Okay, so this they are in a two different scopes. So that's why the code like that could really become a little confusing. So it would be better to have a different variable name for this runny, maybe just uh, character, or something totally different name, so it doesn't basically it doesn't um, uh, confuse us. So anyway, in this case, after it finds a character, okay, that is a vowel, then it is going to append to the slides. Okay, so it is going to append to the vowels. So vowels is a slice, so it will append to the vowels. So vowels is basically a variable of type Rene. This is a Rene is a variable of type each character. Okay, and in here we are just appending the vowels that we find in a string. Okay, and it will be keep doing it. So when we find, so the purpose of this to lower is to, even if it is a uppercase letter, it will make it a lower case and try to match it with one of these characters, which are the vowels in a small or the lowercase. So then once the match occurs, then it will do the appending to this slice called vowels. Okay. So once it is done, then it just returns it wherever this method was called from. So now let's look at this main entry point routine. So in here, very first thing at line number 29, what we do is to initialize the string. Okay, and as you can see, by doing this, we are saying that okay, this string will be of type, this alias. Okay, so that's what basically we're doing. So we are initializing this to the name variable. So once that is done, then we're going to use this name variable to get each or read whatever is in the name variable is. Okay. Um, well, and the name variable will hold this data, a string, game of thorns. Okay, that will be the one which will be in the variable called name. And then we are creating at line number 30. We are creating um, variable v of type vowels finder. Okay. Now, what is a vowel finder? Vowel finder is the interface that we declared earlier. Okay, and that interface says that okay, it will create a relationship between a type. In this case, the type is the my string. Okay, and an interface. So that's what a vowel finder will do. So vowel finder is an interface between a type called my string. Okay, and so that's how the interfaces are created. So after creating the v of type interface, what we are doing is to initializing the name to this v, because v is of type interface. Right here, this is the interface, right? So v is of type interface. That means it can also take a different type name. So in this case, it is taking the string type. So that's why because it's possible since my string implements the vowel finder. So we already have implemented it. That's why this is possible. And then we call the printf function to basically type in the string. So this is the name, and then v dot finder, which is going to be returning the slice of vowels. So this is the slice of vowels that it is returning. Now notice that there is a capital O in here. Okay, so how did that happen? Because there is a capital O or uppercase O in this string. So uh, these are all the vowels that are within this string. Okay, so that's what this method does. It will tell us the different vowels that are used within any string that you give. So you can change the string, and and it will find all the vowels within that string. And then this next, I just wanted to see the type of v. So data type of v. So in this case, as you can see, I'm using a %t. That's how you can find the type of anything that you want with a %t. Of course, you have to use a printf function in this case. So basically, what it is saying, that my string is the type, okay, of what, of this v. Okay, and then the name, okay, type is also my string, because that's what the type is. It's not only the string. Okay, it is the type that we created. So basically, in this example, we went over how to create an interface for the non-struct type. Okay. Um, Now, so that basically concludes Unit 1.